that we will actually be together 4 days this week. Those of us that- Okay. So, we were beginning, I believe, the last sketch. And we had factored out the 1/3. And I reminded you that factoring is division, right? So when I took a 1/3 out of this parentheses, I'm dividing by 1/3, which is timesing by 3, right? We've gotten this far, hadn't we? Yeah. And then, and you will do this however you do it. When I do a cosecant, I start with a sine. So for the time being, I'm going to think of this as a sine. Why? Well, I think I'm just more comfortable with sines because I've done so many more of those. So this is a positive sine curve with an amplitude of 2/5 and a phase shift of 3 pi over 5, or a horizontal shift of positive 3 pi over 5. You with me? Okay. Positive sine curve starting here. So I'm going to go ahead. Here's my positive sine curve. Now my scale is going to be all whopper jawed, but that's okay. We're going to label. So if we had to plot it on graph paper, we could. Now, I need to label the high point, the crossing, the low point, and the end. I know that from here to here is called a period, right? And for a sine, the normal period is 2 pi, once around the circle. But because of that, my period now is 2 pi divided by 1/3, which is 6 pi. So I am starting here and adding 6 pi to get my endpoint. So 3 pi over 5 plus 6 pi. So I get a common denominator, 33 pi over 5. Don't let the pi confuse you. It just goes along for the ride. Now, 3 and 33 makes 36, and half of 36 is 18. So this right here is 18 pi over 5. It's right in the middle. Now, 3 and 18 make 21. Oh shoot, it's not even. So 21 pi over 5 is what I get when I add these two together. Now, dividing by 2 won't work because that's not even. So I'm going to have to multiply it by 1/2. So this is 21 pi over 10. And then 18 and 33, what's that? 18 and 33 is 51, not even, so 51/5 times 1/2, 51 pi over 10. 51 is not divisible by 2. 36 was, so I just said 18. And we're not done. Are you still with me here? We are not done. So what is left to do? 2 things are left to do. One is to go back and remember, this wasn't even a sine curve, it was a cosecant. So wherever it touches the axis, I'm going to drop in an asymptote. because where it touches the axis is 0, and the reciprocal of 0 is undefined. So I need an asymptote there, because I'm doing the reciprocal. So then this little bump becomes a parabola, and this little guy becomes a parabola, all right? So the blue is a picture of that. What still has to happen? I gotta go up 1. So everything is gonna go up 1. Now remember, that's 2/5. So if I go up 1, I'm gonna be up here at 7/5. Would you agree with that? So that guy is, the asymptotes are still there, they don't change. Now, the vertex of my parabola is up here. Now this one is also going up 1. So where's he gonna be? If you go up 1, he's gonna be at 3/5, isn't he? -2 plus 5 is 3. So now my downward looks like that. Now that picture is a disaster. There's a lot going on. The answer is the pink, okay, with the blue asymptotes. Yeah, there's a lot there. So, period, we already said was 6 pi. That means frequency is 1/6 pi. And I do want to caution some of you about the way you're writing these fractions. Okay, when you do this, which some of you do, that is very confusing, because I can't tell unless you put that in parentheses. It looks like 1/6 pi to me. Okay, so you gotta make it very clear that 6 pi is in the denominator. Our phase shift, or horizontal shift, was 3 pi over 5. Our vertical shift was 1. And here's the tricky one. There is no amplitude. Now I know we have labels on our y-axis, but those labels aren't for height. Those labels are to tell us where the vertex is of our parabolas. There is no amplitude. There's no height, it's going forever. Okay, a lot going on here in that problem. Okay, we spent a lot of time graphing over many sorted days. Now we gotta move on, we're gonna solve. I promise we'll do more practice, but you guys are gonna have to do some practice on your own too, to kind of keep us. But let's take a look at number 2 says solve without a calculator. And we are between 0 and 2 pi. Okay, you can do this. First thing that I think, again, because I just don't work very well with secants and cosecants and all that, I'm going to think of this as a cosine. If the secant is 2, does it make sense to you that the cosine is 1/2? Yeah, because they're reciprocals, right? As I go all the way around, so 0, pi over 2, pi, 3 pi over 2, 2 pi. And again, if you're working in degrees, now I need to answer in radians, but if you want to work in degrees, remember pi is 180. There are your degrees. I need to figure out, looking all the way around here, all this is eligible. Where would the cosine be a positive number. Let's start with that. The cosine has to be positive. Eli is going like this. Why is Eli going like that? Because cosine is associated with x. When you draw a triangle, cosine is associated with adjacent, right? That's x. X is positive here and here. If you were over here, do you see how that's negative? So wouldn't your cosine be a negative number over here? Adjacent over hypotenuse? So it's not over here. We narrowed it down. Here's where it's at. Now, adjacent over hypotenuse has to be 1 over 2. That means this side is root 3, right? And this angle is how big? 60. I'm going to do it in radians though. Remembering that pi is 180, what's 60? 1/3. Pi, I'll say pi over 3, but if you said 1/3 pi, that would be the same thing. Jimmy, you with us?
Yep.
Okay, I saw you out there dancing on Friday.
Thank you.
No, I smiled. He did a good job.
Yeah, thanks.
Takes courage. All right, so what are my answers? Well, my blue answer is pi over 3. What is my pink one? Now remember,
240.
these angles are the same size. So if I went all the way around, that would be 6/3, right? 2 pi, 6/3. But if I only go this much, that pink angle will be 5/3. And there are your answers. If you're doing these without a calculator, your angles are going to be 30, 60, or 45, right? So they're going to be pi over 6, pi over 3, or pi over 4. They're not going to be weird things. All right, let's see if we can fight through the next one. The cotangent is negative root 3. All right, I'm going to rewrite that. Tangent is negative 1 over root 3. Does that make sense to you? So what do I need to figure out? Before I start in, what do I need to figure out? Where we're going to draw it. Where are we going to draw it? So stop and think about what tangent is, and you need it to be negative. Where will tangent be negative? Well, it'll be negative here, but it won't be negative here. Why will the tangent not be negative here? Because it's negative, negative. So here, it looks like this. 1 over negative root 3. Where else is it negative? Quadrant 4. Here it's 1 and, oops, negative 1 and negative 3. Now take a look at that, make sure that makes sense to you. Because we're not going to get the right answer if we don't get the right quadrant. That look okay? All right, so now that's a 1, that's a root 3, this is a 2. How big is that angle right there? 30, so pi over 6. Now, don't let the fractions bother you. Guys, this is pi. So that would be 6, 6. So if this is 6, 6, What's this angle gonna be? What's the pink one gonna be? 6, 6 minus 1/6? 5, 6? Look, all the way to here, if I came all the way around, it'd be 6, 6. I stopped with a 6th to go. That's 5/6. This one is 12/6. All the way around is 12/6. If I stop here, go all the way around except for that, 11/6. Now you're getting it, yeah. So your answers are 5 pi over 6 and 11 pi over 6. I want the tangent to be 1. Now I usually write it 1 over 1, so it's a ratio, opposite over adjacent, y over x. So which quadrants? What, Alden?
It'll be the other two.
Yeah, it'll be the other two. Tangent's gonna be positive here, 1 and 1, or here, -1 and -1. So that's a 1, 1 root 2. How big is that angle? 45, which is a fourth of 180. So it's pi over 4. 30 is pi over 6, 180 over 6. 60 is pi over 3, 180 over 3. And 45 is pi over 4. So this one's easy. The pink one is pi over 4. Can you figure out the blue one? What will the blue one be? 5 pi over 4. How did she get 5 pi over 4? This is 1 and a fourth. 4 fourths and 1/4. 5 pi over 4. 1 and a fourth. All right, get your calculators out. Now we're going to do exactly the same thing, but the angles will not be special in any way, so we will have to use our calculator.
How do you know what angles?
One more time. If I'm doing it without a calculator, every angle is going to be 30, 60, or 45, or in radians, pi over 6, pi over 3, pi over 4. Every time, if I don't have a calculator. Now, if I have a calculator, it doesn't really change how I do it. The tangent is 1.75. Which quadrants will I be looking if my tangent is going to be a positive number?
1 and 3.
1 and 3. Now, you don't need to label the sides or anything. I would just say, get this picture up here. Your calculator is going to tell you the angle. How will I find the angle? What will I press on my calculator? Second tangent, 1.75. When you are finding an angle, remember you use these buttons. These buttons find angles. Now, did your calculator say 60?
Yeah.
Okay, that's a degree measure. So we need to go to mode. We need to change into radians. And then do it again. You should have gotten 1.05. You get 1.05. Now, the good news is, you only have to do that once. All the angles in this problem are going to be 1.05. Now you just need to figure out what the answers are. So one of the answers is this pink angle. Oh, that's easy. 1.05. The other answer, though, is the blue one. How will I find the blue one? Well, all the way to here is how far? 3.14 pi. And then I have to go 1.05 more. So I'm going to take second pi plus 1.05. Did you get 4.19? If we then in degrees, so when we first typed this in, I got 60 or something here, right? So one of my answers in degrees would have been that 60, and then the other one would have been 180 plus 60, or 240, if I were in degrees. If I'm in radians, I'm not adding 180. I'm adding pi. All right, let's try the next one. Cosecant equals 7/3. Can you read my mind? Do you even want to read my mind? I'm going to rewrite that as sine equals 3/7. Then before I go to the calculator, and I know I can, and I will, I gotta figure out where my answers are gonna be. There's two answers. All these problems have two answers. So I know one of them will be in quadrant 1, because isn't the sign positive in quadrant 1? Where else is sign positive? Where are you pointing, Jimmy? I can't tell.
I'm thinking about
Two?
Okay.
Quadrant 2?
I heard a quadrant 2. Are we in agreement? Somebody wanna, oh, I see some nods over there. Why is sign positive in quadrant 2? Sign is opposite, or y, the vertical, right? And that's positive up here. Now I'm gonna go to my calculator, and what buttons am I gonna press? Second sine, get rid of that. Second sine, 3 divided by 7. 0.44? What do you think? You good with that? Remember, we're in radians. How do I know I'm in radians? The directions say 0 to 2 pi. 0 to 360 would be degrees. 0 to 2 pi is radians. So, my blue answer is easy. My blue answer is 0.44. What is my pink answer? Now think about it, guys. Remember, this is pi over here. How will I find my pink number? Blake?
Pi minus 0.44.
Pi minus, that's exactly right. Pi minus 0.44. I didn't make it all the way to pi. I had to back up some. So second pi minus 0.44. Did you get 2.70? All right, now the next one is crazy. The next one is absolutely crazy. So we really got to pay attention to what's happening here. First of all, can I change it to a cosine?
But then
2/3.
What's the matter? You okay? Okay. Now, before I go anywhere on my calculator, I need to think about where is the cosine going to be negative.
230.
Cosine's gonna be negative in quadrant 2 and quadrant 3. Because again, cosine is associated with x, or adjacent, and if it's negative, it's over here. Okay? Alright, so now I'm gonna go to my calculator, and I'm gonna do second cosine negative 2/3. Because we're finding an angle, and that's how we find an angle. No matter what, we're finding an angle. Now, here is what happened, alright? And you're either gonna have to remember this, or you're gonna have to deal with it the way I do it. Here's the problem. This angle right here is not 2.30. When I type this in on my calculator, second cosine, I got 2.30. Did you? Did you? Okay. Here's what I want you to do. Change your calculator into degrees and redo the problem. Second cosine negative 2/3. Okay? You get 131? Is it possible for this angle right here to be 131? Is that possible?
No.
Absolutely not. Because you can't have a triangle with a 90 and a 131. Alright? So here is how I handle these. I never type the negative in. The negative makes things, I think, harder. So instead of typing in negative 2/3, I'm going to type positive 2/3. So go back to radians and type it in again. So second cosine 2/3. Did you get 0.84? All right, that's your angle. Now, it isn't the answer, okay? It's not the answer, but it is the angle that's in the triangle. If you are trying to figure out the angle in the triangle, do not use the negative. The negative is important to figure out which quadrant I'm in, but don't type it in. Now, look at this. Can you find out how big the pink angle is? Remember, this is pi. What will the pink angle be?
2.43.
Oh, have we seen that before? Isn't that what my calculator said when I put the negative in? Well, Mrs. Ford, why didn't we just use it? Well, here's the problem. I still have to find this one. How am I gonna find the third quadrant angle? How am I gonna find that guy?
0.84.
Exactly. Pi plus 0.84.
You should just do 2.35. So we should be able to get
3.98. That problem's hard. Alright, we're gonna do one more section. This section will go fast. 4-6 is super simple. Oh, by the way, we just finished 4-5, right? Yeah, so that homework will be due Wednesday. We're gonna finish 4-6 also, but I'll make that homework due Thursday, so you don't have two due on the same day. Or you can do them both on the same day and turn them in tomorrow. I don't care, it doesn't matter. But 4-5 is officially Wednesday, 4-6 is officially Thursday. But this is so easy. Sketch on a calculator. All right, so we're already in radian mode, right? Okay, let's go to window. And the directions give me x min and max. So for x min, go to window, for x min type -2 pi and use your pi button. For x max, type +2 pi using your pi button. Now, it will change it into a decimal, and that's okay, but when you type it in, go ahead and use your pi button. For y min and max, let's go with -2 and 2. Okay, everybody good so far? All right, now go to y equals, clear out anything that's in there already, and we're gonna type in our equation. Now, you're going to type it carefully, because you are squaring the whole sign. So when you type it in, you're gonna have parentheses, you're gonna hit sign, another parentheses is gonna come up, you're gonna put an X in there, close it, and put squared. That's the way you're gonna have to type this in. Okay, so type that in just like that. And hit graph. I'm not a very good artist, but did you get something that looked like that?
Yeah.
All we gotta do is grab that.
Why is one?
No numbers.
Wait, parentheses, sign.
Okay, everybody, get that picture? Did you get that, Michael?
I did.
Perfect. All right, so now we're going to B.
Bro, how did you?
That's it.
I just put my.
Now, B is easier to type in, just type x squared, so x squared plus 2 sine x.
Mine's up.
Now, my window was kind of small, so let's change our y's to maybe -20 and 20. And see if that gives us anything else to look at. Not really. Did it give you something that looked like this? I changed my y's to -20 to 20. Looks like something like this. Did you get something that looks sort of like that?
Yeah.
Now, I am not surprised by that shape, because what is x squared? A parabola. So I'm combining a parabola with a sine, and so I kind of get a squiggly parabola, because a sine is a squiggly line, so it's kind of a squiggly parabola. This is only for observation, all right? I'm not gonna ask you any questions about it. Just need to be able to type it in, following the directions. This is what we get. The problems are in the next section. Is it a sinusoid? Why or why not? What is its period? Okay. So,
That's a long split.
let me show you how you tell if something is sinusoidal or not. Sinusoidal simply means it has all the characteristics of a sine or a cosine curve. So how you tell is you find the period of each piece. So what is the period of this piece?
Pi.
2 pi.
2 pi. What is the period of this piece?
Pi plus 3.
Remember, that's an amplitude.
It's 2 pi. That's just
The period is controlled by this number, so it's also just 2 pi. Remember, to change the period, you have to have a number here. right? So if there's no number there, then the period hasn't changed, and sine and cosine are both 2 pi. If those numbers match, the thing is sinusoidal. So since the periods are the same, it is a sinusoid, and its period is 2 pi. What that means is, and if we have time, we'll do it, but I want to get through all these. What that means is, if you graph this, like we just did, type in this equation and graph it, every 2 pi, it's going to repeat itself. Okay? Perfect. All right, letter B. Find the period of each piece. So what is the period of the first piece right here? What is this period?
2 pi.
2 pi. What is this period? It's a tangent now. What's the period of the tangent? One pi. That was probably in some video you were sleeping through. Tangent, period's pi. Unless you put a coefficient there and then it divides it, just like always. Now, do they match? No. So this is not sinusoidal, but it still has a period. It's still going to be periodic. Here's how you figure that period out. If the period is 2 pi, then that means every 2 pi, I repeat myself. So for this guy right here, I go 2 pi, and then I do it again, and end at 4 pi, and then I do it again, and end at 6 pi. Does that make sense to you? Now what about this one? He repeats every pi. So pi, 2 pi, 3 pi, 4 pi, and so on. The first number they have in common is the period. So this one starts over again at 2 pi, and this one also starts over again at 2 pi. So the period of this is 2 pi. That's where they both start over again. See, I told you it was easy. It's really easy. Okay, C. What is the period of the first curve? This guy, what's his period? No. It would be 2 pi, but it's been divided by 2. So it's 2 pi over 2, which is pi. Remember, this number divides the period. The normal period of the sine is 2 pi divided by 2. Now what about this guy? What's the period of this one? 2 pi divided by 5? So is it a sinusoid? No, because it's only sinusoidal if they match. They don't. Okay. So now I gotta figure out where they both start, again, where do they overlap at their starting? So this one is pi, 2 pi, 3 pi, da-da-da. Now this one is 2/5, 4/5, 6/5, are you with me? 8/5, 10/5, wait a minute, what's 10/5? So what is the period? 2 pi. They overlap the first time at 2 pi. What?
Oh, it's 5 and 5.
What? less chance of just higher.
I don't know,
It's just
when
like
you
this,
graph
this
it,
is-
it's asymptote to asymptote,
this is what
it's
it is.
positive. All right, let's try the next one. What is the period? What is the period of this guy?
High.
Pi. 2 pi divided by 2. What is the period of this one? 2 pi over 3. 2/3 pi. Not sinusoidal. So is it a sinusoid? No. But it does have a period. It is periodic. And its period would be what? 2 pi again? I'm not really surprised by that because 2 pi is a pretty important number. But does everybody see why it's 2 pi right here? All right, would you try E? You and your partner try E?
Yes, you agree.
Remember, this number is a divider. So I got a period of 1 for both of them. Is it sinusoidal? Yep, and the period is 1. Last one. Okay. Now, if I were gonna graph it, I would absolutely pull that 2 out. We talked about that. But I am not graphing this, I am only finding the period. So won't the period, if I factored this out, I'd have a 2 out here. Won't my period just be 2 pi divided by that 2? I'm not graphing this, thank God. I just wanna know what the period is. So it's gonna be 2 pi divided by that coefficient. What's the period of this gonna be? 2 pi over 3? I think I already did this one. I mean, one like this, but let's go ahead and write it out. Not sinusoidal, right? Not a sinusoid, but our period is 2 pi. Right? Okay, I'm gonna stop there and I wanna answer some questions about all the papers
So what
that I
is that
turned
for?
in. Huh?
Is it 4.5?
Is due Thursday, no, 4.5 is Wednesday, 4.6 is Thursday.
Okay, yeah.
But you can do it, I mean,
Yeah, I know, I
4.6 is gonna take you about 4 minutes, max. All right, so whether it was a homework paper or a quiz paper, who has a question about something that I have returned to you? Jada?
On the quiz, number 1,
Exact value of sine 7 pi over 6? Okay. This is kind of the backwards of what we were doing in our notes a minute ago. I know the angle, the one we just took. I know the angle. it's 7 pi over 6 radians. I might wanna think of that in degrees. 7 pi over 6 would be 210. And so I'll figure out where that is on my setup here. Won't 210 be right here? So I make my triangle. Then this angle is 30 because it's from 180 to 210. So this is 1 and these 3 and 2, those are my numbers. And these are both negative because I am in quadrant 3, so left and down. And then I'm doing sine, which is opposite over hypotenuse. Negative 1/2 should be the answer. Is that what you have?
No, I put 30 degrees as the answer, sine 30 degrees.
Okay. You got it now, though, what you're supposed to do? Yeah. So we're supposed to be finding the sine, the actual sine value. Yep.
You do number 2.
2 says find the arc length. I don't know about you, but when somebody says to me arc length, I immediately think radius times radians. Now, if you think radius times angle, you're right, but the angle has to be in radians, so you can't do 6 times 80. That won't work. You have to have 80 changed into radians. Anybody remember how to do that?
Pi over 1.
Yep. So pi over 180 equals something over 80. I want to know how many radians go with 80 degrees. So 180x equals 80 pi. I can reduce, I got 4 pi over 9. Ben, you with me still? Now, 4 pi over 9 is not the answer to the question. Some of you wrote that down as the answer. 4 pi over 9 is the angle in radians. To get the arc length, I have to multiply that times my radius. So I get 24 pi over 9, which reduces to 8 pi over 3 inches. So your answer is 8 pi over 3 inches. That's a 2-step problem. And several of you did this perfectly, but stop. You need to multiply that times the radius. All right, anything else from the homework or the quiz I turn back?
I do have one, just looking over 4.5, number 2. It doesn't,
It doesn't what?
it just doesn't look like the ones that we've done on the 4.5, so wondering how like to set it up.
But it does, yeah, because you have to do a little arithmetic to get started. So we have root 3 secant plus 2 equals 0. Now this is an equation we are solving. So the first thing we're going to do is subtract the 2. And then we will divide. And then it looks exactly like the ones that we were doing. I would change this into a cosine. Right? And then figure out where to draw my triangle. This is by hand. This is no calculator. So I need to figure out where to draw my triangle, and then I have to figure out what my angle is. Remember, boys and girls, if we don't have a calculator, what is our angle gonna be? Pi over 6, pi over 3, or pi over 4? Those are your options. So which quadrants am I in?
Pi over 6.
Cosine is negative. would be here and here. And if this is root 3 and 2, that's 1. Which means this is 30, but I'm answering in radians, pi over 6. This one's also pi over 6. So now I need my blue angle. Don't make this hard. This is pi. This one's gonna be pi minus a sixth, which is 5/6. And the other one is gonna be pi plus a sixth, which is 7/6. So there are the two answers to that problem. So he's right. You had to do a little bit of work here to get it to look like the other ones did. All right. One of them is due Wednesday and one of them is due Thursday, but you can put them both in together.
There is